Okay, these are your notes for 4.4. This is geometry. And we're talking about triangle congruence. And in specific, we're going to be talking about side, 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 and side, angle, side today. Now, before we get into it, I just want to remind you of some things that we've talked about previously in the last few days. So when we did our activity in class the other day, and we cut out our triangles, we had 7 different types of triangles that we made. There were 2 of them that could not be utilized to prove triangle congruence. And do you remember what they were? I hope you remember that one of them was angle, 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 and the other one was side, side, angle. When we made those triangles and everyone had the same directions, these ended up being different sizes. And so even though they were following the same instructions, they came out with different sized triangles. So we cannot use these two to prove triangle congruence. And so I told you to try and remember this by, like, the 3 A's were like, we can't use those, Or maybe you think about triple A. You call triple A when your car is broken down, and so that's never any good. So we can't use angle, angle, angle. And then this other one, SSA, if we were to read that backwards, it makes a bad word, and so therefore it's kind of bad. We can't use that one. It's never going to work. Okay? So those two are not possible for proving triangle congruence. But on the other hand, the other ones that we did are usable when we're doing proofs. And what's nice about those, if you remember from our notes from a couple days ago, what we had to do in order to prove that 2 triangles were congruent, if we had to prove that there were 3 sides that were congruent and 3 angles that were congruent. All 3 sides, all 3 angles. And these theorems that we're going to use are going to help you, theorems and postulates, they're going to help you be able to prove that without doing all 6 steps. We can go down to 3 steps, which is always better. It's always better to have a shortcut, right? Okay, so we're going to jump into the lesson now. So let's look. We're going to start with the side, side, side postulate. And so side, side, side congruence is if 3 sides in one triangle are congruent to 3 sides in another triangle, then the triangles are congruent. Okay, so let's take a look at our first example. We are given true triangles here, and these little tick marks show congruence. You have 1 and 1, that means those 2 sides are congruent. Then you have the 2's, so those 2 sides are congruent, and then 3 right there. So let's write them out. So this first side, we see that MN is congruent with which side over here? QR. And side NP, right here, is congruent with RS. And then MP is congruent with QS. Okay, so if those things are true, then we can say triangle MNP, and generally we're going to write the name of the triangle, try to do it in alphabetical order, but just remember that no matter what order you put it in, because it isn't necessary to put it in alphabetical order, but whatever order you put it in has to match, the second one has to match it. So if we start with M on this one, we have to start with Q on the next one. And then when we go to N, we move to N here. That means we've got to move to R on this one. And then if we go to P here, then that's going to be S. So triangle MNP is congruent with triangle QRS by what postulate? Side, side, side. Okay, so there we go. Let's look at example 1. Okay, so it says write a congruent statements between triangles and state the postulate implied. If you cannot apply a postulate, write no conclusion can be made. Okay, so let's look at the picture we're given here. We can see right now that QT is congruent with RS and QR is congruent with ST. Is there anything else that you noticed about that picture? Any other side? Because we're looking for 3 sides. And what would you say? We could say that TR is a shared side by both triangles. And can we say that RT is congruent with RT? Yes, we can. What would be our reason for that? And what property are we using there? I hope you remember. That's the reflexive property. So we have our 3 sides. QT is congruent with RS, TS is congruent with QR, and RT is congruent with RT. And so we can make a congruent statement, triangle TQR. And now let's look at the order I did that. We went from T to Q. And so we're going to go is congruent with R to S. And then we're taking the small side here. TQRRST. By what postulate? Side, side, side. SSS. Okay, example 2, write a congruent statement between the triangles and state the postulate. If you cannot, write no conclusion can be made. So let's see here. It tells us that M is the midpoint of LN. Okay, and so what can we conclude if we know that M is the midpoint of LN? Well, we can conclude that LM is congruent with MN, definition of a midpoint. Creates 2 congruent segments. Okay, then we are given that KL is congruent with KN, so we have this. Now, what else? Anything else that we can conclude about this triangle? Well, yeah, we can say KM is congruent with KM, reflexive property. And so can we make a statement about these? I believe so. We could say that triangle KLM is congruent with triangle KM. Oh, no, we want to do it in the same order. We went KLM, so we're going to go KNM. So I want to fix that. KNM by side, side, side. Always put them in the same order. We went from K to L, so we're going to do K to N, and then L to M, so N to M, like that. Okay, now let's look at example 3. Okay, on example 3, it says complete the following proof. Given AB is congruent with BC, so let's mark that AB is congruent with BC, and D is the midpoint of AC, prove that triangle ADB is congruent with CDB. Okay, so now let's think about this. If we have a midpoint, what do we know about a midpoint? What statement can we say as a result of a midpoint? We get two congruent segments. So let's write our proof statements down here. Let's start with number 1. Let's do our givens. We have AB segment is congruent with BC, given. And then number 2, we have D is a midpoint of AC. That's given. And now, as a result of our midpoint, we can say AD is congruent with DC. And how do we know that? Definition of a midpoint. Now, let's think about what else we know. What else can we conclude on this triangle? Well, we can say that BD is congruent with BD. And how do we know that? That is the reflexive property of congruence. And so now what can we say? We can say triangle ADB is congruent with triangle CDB. And what's our reason for that? Our reason is side, side, side. Now I want you to remember, anytime you're giving a proof, anytime we come to a conclusion and we say this is the reason, there has to be statements that we've made on here that give us the ability to write this down. So let's look here. Let's find where we prove this SSS in our proof. Well, in statement 1, we have AB is congruent with BC. There's one side. Now the midpoint statement doesn't do anything for us, but here on statement 3, we have AD is congruent with DC. There's another side. And then we have BD is congruent with BD. There's the other side. You have to have all 3 statements somewhere in your proof in order to be able to write it down like this as a reason. Okay, so we have them all right there, side, side, side. So we, in statement 1, in statement 3, and statement 4, we have adequate proof for these 2 triangles to be congruent. Okay, let's move on. Okay, I'm going to pretty well skim over example 4 because we've just done a couple just like it. Use side, side, side to explain triangle ABC is congruent with triangle CDA. Well, we have one side congruent, second side congruent, and where's our third side? This side that's shared angle AC, or segment AC, which is congruent with itself, reflexive property. Okay, so now let's jump in here to example 5. And before we get to example 5, I want to talk about what we mean by an included angle. An included angle is the angle that's formed by 2 adjacent sides of a polygon. So yes, it could be any type of polygon. We're concentrating on triangles here, but this is the included angle is always going to be the case. For any polygons, it's going to be the angle that's formed by the 2 adjacent sides. So if we look at this triangle, what is the included angle of? What's the included angle of segments BA and AC. What's the included angle? It's the angle that's in between. That's going to be angle A. Oh, and here, look at it. See, right here, AB. I got ahead of myself. Let's look down here. AB and BC. Here's AB and BC. What's the angle? That's the included angle. It's the one that's in between. Is going to be angle B. Okay? Angle, or line segment AB and line segment AC. What's the included angle? It's going to be angle A. And then finally, we have angle, or I keep saying angle, line segment BC and CA. And what's the included angle here? Is going to be angle C. Now, I want you to write down this postulate. Okay, side angle side states if two sides and the included angle. Now, this is really important because I want to just kind of just say one more time. Like, if we're talking about AB and BC, you see here's a side, and here's the angle, the included angle, side angle side. If we were to look at this picture and we had a side, and then the angle over here, that's going to be side angle. And you know what we have to say about that? That is bad, can't be used. So we're talking about the included angle in this postulate. So we have if two sides and the included angle in one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Now, aren't you happy to know that I'm not going to make you write all of this stuff down when you're doing your proofs? We can just write SAS. See? Aren't I nice? I'm a nice person. We'll just write SAS. Okay? So, let's take a look down here. We got some little examples. Let's see what we can figure out. Let's look at these two triangles and see if we can make any conclusions. Can we find two sides that are congruent? Well, we can see here that PQ has a little tick mark. PQ is congruent with WX. And then, how about an angle? We have angle Q. Do this in green. Angle Q is congruent with angle X right here. And then we can see that QS is congruent with XY. And so we can make the conclusion that triangle PQS, so P to Q is the side with one tick mark, so we want to do that over here, is congruent with WXY. How do we know that? By side angle sides. Now, if I gave you a little picture that looked like this, and I have angle could I make the same conclusion about these two triangles right here? And the answer would be no conclusion. Why? Because even though there's two sides that are congruent and one angle, It's not the included angle. The included angle is the angle that's in between those two congruent sides, and this one here is not. So there would be no conclusion. Okay? So now let's look at examples 6 and 7. Okay, so on example 6, let's see what we can figure out. We see that AB is congruent with DC, and we see that angle A is congruent with angle C. Is there anything else that we can conclude? Well, we know that AC is congruent with AC. So can I state with authority that triangle BAC is congruent with DCA, making sure we're going in the same order, BAC and DCA, by, how do we know that? Side angle side. Because we do have two sides and the included angle. Two sides and the included angle. So it's the angle in between the two sides. I want you to try example 7 yourself. Hit pause and decide what kind of conclusion you can be made. Okay, well, the fact is on this picture, we can make no conclusion because we have an angle that's congruent. We see another angle that's congruent. And we do have a theorem that says if two angles of one triangle are congruent with two angles of the other triangle, then we know the third angle is congruent as well. But what does that do for us? That's angle, angle, angle. Ah! We can't use that. It's not bad news. So we can't use angle, angle, angle as a means to prove that. So no conclusion. Okay, on example 8, we need to complete this following proof. It says, given that M bisects PN and KQ, prove that PMK, triangle PMK, is congruent with triangle NMQ. So let's figure out what we know. It says that M is bisecting both of these at the same time. And so if we look at PN, and we've got M as a midpoint, we know that this line segment is congruent with that one. And what else? We know that this is going to be congruent with that. And how do we know that? Because we know from a definition of this is a segment bisector. It's not an angle bisector. It's because it's bisecting a line segment. And when we have a segment bisector, we know that gives us a midpoint. And when we have a midpoint, what does that prove? We have two congruent segments. So these are the statements that we're going to have to use in our proof to work out our final conclusion right here. So let's start with our given that M bisects PN and KQ. How do we know that? Given. Now let's just do these one at a time. Let's start with M. M is the midpoint of PN. And how do I know that? That would be definition of a segment bisector. And as a result of that, we know that PM is congruent with MN. And how do I know that? Definition of a midpoint. And now we're going to have to go through the same statements again using KQ. And so we'll say M is a midpoint of KQ. How do I know that? Definition of a segment bisector. And what do I know as a result of that? We know that KM is congruent with MQ. Definition of a midpoint. Okay, so now, what can we say? Let's look here. We have two sides. We need to figure out, is there an angle that we can prove is congruent? And I want you to look at the picture and notice that we have some vertical angles. And there's actually two pairs of vertical angles. We've got this pair right here, but that doesn't really help us in our proof because those are not the included angles. Remember, the included angles are the ones that are in between our two adjacent sides. So we're going to use these two angles. And how would we name those? Remember, we want to always name it with the middle one as our angle. So we're going to say angle KMP is congruent with angle QMN. Remember, always do them the same way. This is the side that has the two tick marks, KM, and it started out here. So we want to start with QM on this one, QMN. And how do we know that? All vertical angles are congruent. And then finally, our concluding statement is going to be triangle PMK is congruent with triangle NMQ, and we're going to say that by side, angle, side. Now let's go back up here to our statements and make sure, like we did previously, that we have all of these things somewhere in our statement. So let's take a look here. Well, here on statement 3, there's a side, and then we have KM is congruent with MQ. There's a side, and we have angle KMP and angle QMN, so there's our angle. Now, even though these are written in the order side, side, angle, because you might think, uh-oh, we can't use that, but that's just the order we prove them. When you look at your picture, it's side, angle, side. It is the included angle on our picture. So even though we proved them in a different order, that doesn't matter. We still have the proof that we need because the angle is the included angle. And statement 3, statement 6, statement 5 are the ones that help us out here. Okay? So we're almost done. Okay, just in the interest of time, I skipped example 9. Let's jump to example 10. And let's see here. It says, in the diagram, BD bisects angle ABC. So what do we have here? What kind of a bisector we have here? This would be an angle bisector because it's bisecting an angle. And what do we know? What can we conclude about an angle bisector? It's going to create two congruent angles. Okay, so what additional congruence must be established to prove that this triangle is congruent to this triangle using side, angle, side? Well, let's see here. If angle, or if this line segment BD bisects angle ABC, we know that this angle is congruent with this angle, definition of an angle bisector. And if I wanted to use side angle side, well, the other thing we know for sure, looking at the picture, we know for sure that BD is congruent with BD. So if I wanted to be able to prove this, these two triangles congruent, the other proof we would need is for AB to be congruent with CB. That's what we need. AB needs to be congruent with CB. Now, why not AD and DC? Because if I prove those, then I would have a side, and an angle. And we know what happens when we have a side-side angle. It's the bad thing, doesn't work. So, yeah, AD and DC aren't going to help us. We need to prove that this side is congruent with this one right here. Okay, to make sure we have the included angle in order to do our proof. Okay, now let's finally, example 11. Okay, now pay attention to example 11. I know this video, we're in 30 minutes now, but these are the kind of questions that come up on quizzes and tests. Okay, you have two triangles, UTW and AXM. Okay, and it says that angle U is this and angle A is this. Now let's look on our letters here. U is in the same position as A, and so what do we know about those two angles? If these two triangles are congruent, then we know the two that are in the same position are congruent as well. So we can solve this by setting these two equal to each other. 4x plus 23 equals 6x minus 15. And now let's solve for x. So let's see here. I'm going to take baby to mama right here. And we get 23 equals 2x minus 15. Add the 15. And we get 38 equals 2x. Divide by 2. And x equals 19. Now that I know that x equals 19, let's see what we can figure out. Let's take a minute to make a little drawing here. If I have U and T and W, and we take our 19 and plug into U, U is going to be 4 times 19 plus 23, and that's going to be 76 plus 23 equals 99. So angle U is 99. And then let's see here, angle A is going to be 99 as well. Let's see what else we can find out. The measure of angle T is 2x minus 3. So we're going to do 2 times 19 minus 3, and that gives us 38 minus 3 equals 35. So this is 35. And so now, can we figure out the measure of angle W? Yes, add these together and subtract from 180, because the three angles need to add up to 180. So we know this one's going to be 46. The question says, what's the measure of angle M? And let's look. M is in the same position as the W angle, so we know that angle M, the measure of angle M, is 46 degrees. Okay, I know that was kind of a long video, but that's the way the cookie crumbles geometry-wise. And hope you're learning something. Okay? See ya. Bye.